So when we're trying to prove identities, proving identities, it's working with the identities that we know to come up with new ones, basically, to prove that the statement that we're saying about different trig identities is true. So there's two strategies. So the first one is to make one side look like the other. Make one side look like the other. And then if you can't do that, another strategy is to make each side look the same. Make each side look the same. So work on each side to make them look the same. One thing that's a little different though with proving, we're not going to do things to both sides or move things from side to side. We either just work on one side or work on each side separately, but we don't move side to side of the equal sign, like with solving equations. So let's say, for example, I have that cotangent squared x times tangent squared x plus 1 equals cosecant squared of x. Okay, so this one, I'm looking at this. The right side's already kind of simple, so I think maybe strategy 1 might work, where I just do things to the left side and see if I can make it look like cosecant squared. So one thing I'm noticing right away, tangent squared x plus 1. That's one of my Pythagorean identities. Tangent squared plus 1 is the same as secant squared x. So it helps to have the your identity sheet handy, where you can look at, try to find something that matches. So 1 plus tangent squared is secant squared. And bring down cotangent squared x. These are times. Now I'm kind of thinking, well, cotangent, I know that that is cosine over sine. So cosine squared x over sine squared x. And then I know that secant squared is 1 over cosine. So secant squared x is going to be 1 over cosine squared x. So now I see that my cosine squareds cancel. I'm left with 1 over sine squared x, which is equal to cosecant squared x. So I got the left side, I kept working it out until I got it equal to the right side. So this proves it. I mean, I could keep bringing down the cosecant squared x, but I don't really need to because I'm showing that all of this is equal to cosecant squared x. Okay, so that's an example where I use strategy 1. Let's do another one. That up, I think we've got room. So now the next one, let's do tangent squared x. Well, let's use theta this time. Tangent squared theta over secant squared theta equals 1 plus cosine theta times 1 minus cosine theta. So in this one, it looks like there's kind of a lot going on both sides, so I'm going to try to simplify on both sides. On the left side, tangent, typically when I see tangent, I'm going to rewrite that as sine over cosine. So sine squared over cosine squared. All over, secant squared is going to be 1 over cosine squared. So notice, the cosines are going to cancel because this is divided. That's going to change to, let me write it out this way, sine squared divided by cosine squared. Instead of divided by 1 over cosine, I'm going to flip it, multiply by cosine squared over 1. So cosine cancels. I'm just left with the sine squared of theta. And hopefully that's all I need to do since I ran out of space. Okay, so that, I kind of simplified down the left side as much as I could. Now on the right side, okay, here, I'm going to have to FOIL. I've got 2 terms by 2 terms, binomial by binomial. So I'm going to FOIL. First is 1. Outer is a minus cosine of x. Inner is plus cosine x, theta actually. And then last is minus cosine squared theta. So the cosines cancel out. I'm left with 1 minus cosine squared theta And that, if I kind of need to make sure, I'm going to over to the side work out sine squared plus cosine squared theta equals 1. So that means sine squared is 1 minus cosine squared. So yes, 1 minus cosine squared is sine squared theta. So I got both sides to be sine squared theta. So I proved that this is true.